Okay, so as I've told you that the resistivity of the two wires is same, so their ratio will come up to rho upon rho. So the ratio will be 1:1. So here we'll sum up our numerical number 8. So in first case, the ratio of resistance is 4:1, and in the second case, the ratio of specific resistance will be 1:1. So let's move on to the next numerical, and that is numerical number 9. It is asked over here that a given wire of resistance 1 ohm is stretched to double its length. What will be its new resistance? So first of all, as we know that the formula for resistance again will be rho into L upon A. L is the length, A is the area, and rho is the specific resistance. What is asked over here? It is asked that a given wire of resistance 1 ohm, that means R is given to you, resistance is 1 ohm, is stretched to double its length. It means that in the starting the length of the wire is L, and if the new resistance come up, in that case the length will be double. That means length will be 2 into the length at starting. So let's consider it as L dash. Okay, so as you know that resistance of a conductor is directly proportional to length, so if length is doubled, but as we know that the resistance is inversely proportional to area, so if the length will be double, then resistance will also get doubled, but if the length is double, then area will be reduced to half. So the area will be turned up to A upon 2. So we can write it here that the new resistance R dash will be, as we know that the old resistance is rho into L over A. So new resistance, suppose I'll mark here the area as A dash and length as L dash. So new resistance will be rho into L dash upon A dash. Rho will be same because there is only one wire, and in that case the resistivity in both cases will be same. Only what is changing here? Only the resistance is changing here. R dash rho L dash, in the terms of L it is 2L over, and area A dash is equal to A over 2. So that will come up to rho into 2 into 2 into length over A. So that will be 4 into rho L over A. What is it? This is the old resistance. So I'll put here the value that R dash will be 4 into rho into L over A, and that will be 4 into, this is R, so R dash will be 4 into R, and R dash will come up to 4 into, as the value of R is 1 ohm, so I'll put here the value of R, and R dash will come up to 4 ohm. That will be your answer, right? Next is the numerical number 10 is there. Same is the case with this numerical, that if the resistance of the wire is 3 ohm and the length 10 centimeter is stretched to the length 30 centimeter, assuming that it has a uniform cross section, what will be its new resistance? Same is the case here. Now let us consider the resistance. Resistance is again rho into L over area. Length is 10 in the starting, and resistance is 3 ohm. right? So we'll have to calculate the new resistance. If I'll have to calculate the new resistance, so its formula will come up to rho into L dash upon A dash. Now L dash basically here is 30 centimeter. L dash here is 30 centimeter, right? So if we'll compare both the lengths 10 and 30, so from here we can see that if at the starting the length is 10, so the changed length will be 30 centimeter. So basically this is 3 times 10 centimeter. So this is 3 times L. If the length is 3 times L, so as you know that resistance is inversely proportional to area, so area will be reduced to A dash will be A upon 3, right? So I'll put here the values. R dash will be rho into L dash is 3 into L over area A dash will be A over 3. So that will come up to 3 into rho into 3 L upon A. So that will come up to 9 times rho into L over A. So 9 times rho is same here, rho into L over A. Now let's move on to the next numerical, and that is numerical number 10. So what is given here, that a wire of resistance 3 ohm and length 10 centimeter is stretched to length 30 centimeter, assuming that it has a uniform cross section. What will be its new resistance? So we'll have to calculate the new resistance. So what is given here, that the resistance, old resistance of the wire is 3 ohm and its length is 10 centimeter. And now if the length of the wire is stretched to length 30 centimeter, so here what we can sum up is old length is 10 centimeter and old resistance is 3 ohm. What is the new length? It is 30 centimeter. So how we can write it as 3 into 10 centimeter. So 3 into 10 centimeter basically is the old length of that particular wire, right? So that means that the new resistance is 3 times the old resistance. So as you know that resistance is directly proportional to length. If the length is tripled here, then the area will be 1 by 3 times the original area or old area. So if we'll have to calculate the new resistance will be rho into R dash will be rho into L dash upon A dash. So L dash here is 3 into L, right? And A dash here is A upon 3. I'll put here the values and will come up here 3 into rho, that will go upside, and rho into 3 into L over area. So we'll sum up here with 9 into rho into L upon A. This is what? This is old resistance. So I'll put here the value, and R dash will come up to 9 into R. So R dash will be 9. R is given over here and that is 3 ohm. So R dash will come up 27 ohm. Right? So here we'll sum up with our numerical, and that is numerical number 10. Next numerical is same as that of the numerical number 11, that you can do by yourself. And next numerical, 12th numerical, what is given here? It is asked here that what length of copper wire of specific resistance 1.7 into 10 raised to power minus 8 ohm meter and radius 1 mm is required so that its resistance is 1 ohm. So let's start up with this numerical. What is given here? Here First of all, specific resistance, that means rho is given, and this is 1.7 into 10 raised to the power minus 8 ohm meter, and radius is 1 mm, right? And we'll have to calculate the length of that particular wire, and resistance here is 1 ohm. Okay, so as R is 1 mm, 1 mm means 1 millimeter, and that is equal to 10 raised to the power minus 3 meter. So as we know that the value of or formula for resistance is rho into length over area. What you have to calculate is length, so length will keep it on one side, and that will come up to R into A upon rho. R here is 1, area, as we know that in the case of wire, area is pi R square, pi into R square. R here is 10 raised to the power minus 3 square, so that will come up to 10 into 10 raised to the power minus 6. So area will come up here. Pi is basically 3.14 into 10 raised to the power minus 6 over rho is 1.7 into 10 raised to the power minus 8, right? So 3.14 upon 1.7 into 10 raised to the power, this is minus 6 and here it is minus 8. How to solve it? 3.14 upon 1.7 into 10 raised to the power minus 6, this is minus 8, so upside it will come up to plus 8. 3.14 into 1.7 into 10 raised to the power 2. This is 10 raised to the power 2. So by calculating all this, you will sum up with the value. Your value will come up to 184.7 meter. So like this, you can calculate the value of length, right? In the next numerical, what is asked over here? A filament of bulb takes a current 100 milliampere when the potential difference across it is 0.2 volt, and when the potential difference across it becomes 1.0 volt, the current becomes 400 milliampere. Calculate the resistance of the filament in each case and account for the difference. Okay. So in the next numerical, first of all, you will have to write that what is given. In the first case, current is given to you in the numerical number 13. So current is 100 milliampere and the potential difference is 0.2 volt. This is first case, and in the second case, the potential difference, it becomes 1.0 volt. And current here is 400 milliampere. So in the first case, as we know, according to Ohm's law, V is equal to IR. So R will be V over I. So V is 0.2 and I is 100 milliampere. So 100 milli means 10 raised to the power minus 3 ampere. So this is 0.2 upon 100 into 10 raised to the power 3. So this is 100 means 10 raised to the power 2 into 10 raised to the power minus 3. So that will come up to 0.2 upon 10 raised to the power 2 minus 3. So 0.2 upon 10 power minus 1. So 0.2 I can write it as 2 upon 10 into 10 raised to the power minus 10. That will come upwards. 10 they'll cancel out. The resistance here is 2 ohm, right? And here again we'll have to find out the potential difference. So R here will come up to V upon I, and V again here is 1 volt upon 400 milliampere. So 1 upon 400 into 10 raised to the power minus 3 ampere. So 1 upon 4 into 100 into 10 raised to the power minus 3. 1 upon 4 Again that will be 10 raised to power 2 into 10 raised to power minus 3. So 1 upon 4 into 10 raised to power 2 minus 3. 1 upon 4 into 10 raised to power minus 1. So that will come upward. So 10 upon 4. 5 upon 2. So that will come up to 2.5 ohm. So we can say that in the first case the resistance is 2 ohm. In the first case the resistance is 2 ohm, and in the second case the resistance will come up to 2.5 ohm. What does that mean? If there is increase in temperature, then the resistance of that particular instrument will be increasing. So this is your answer. Resistance of filament in each case, in first case it is 2 and in the second case it is 2.5 ohm. Why is it so? Because as the bulb will start glowing up, the temperature of that particular filament will be increasing, then the resistance of that filament will also be increasing, right? So at this point we have completed the numericals of exercise 8A, and the numericals of 8B will be uploaded very soon. Okay students, so thank you so much.